Here, we're going to take a closer look at the derivative of sine and show how we can find that derivative using the limit definition of the derivative. To do this, we're going to need three facts. We're going to need the special limit, that the limit as h approaches 0 of sine of h over h equals 1. We're going to need the special limit that the limit as h approaches 0 of cosine h minus 1 over h equals 0. And we're going to need the sine angle addition formula, that sine of a plus b is sine of a cos of b plus sine of b cos of a. There is a nice geometric proof for the limit as h approaches 0 of sine of h over h that I encourage you to look into because it's pretty cool. And then once you have this limit, it's actually pretty easy to get this one. So let's go ahead and use these to prove that the derivative of sine is cosine. So we're going to go ahead and start by using the limit definition. And while we have two definitions, one using b index and one with h approaching 0, we really want to use the h approaching 0 one here, because we'll need to be able to use that sine addition formula. So we'll have sine of x plus h minus sine of x over h. And the first thing we're going to do is use that addition formula. That will give me that the limit as h approaches 0 of sine of x cosine of h plus sine of h cosine of x minus sine of x all over h. And one thing we'll notice is that we have two terms that have a sine of x in them. So let's go ahead and group those together. So we'll have sine of x cosine of h minus sine of x. So we'll group that together. Plus sine of h cosine of x. All of that over h. And let's go ahead and split this into two pieces. While I'm splitting it, I'm also going to go ahead and factor out a sine of x here. So this is going to be the limit as h approaches 0 of sine of x times cosine of h minus 1. When you factor out sine from sine of x, you're just left with an h, or with a 1. So we'll have sine of x times cosine of h minus 1 over h, plus the limit as h approaches 0 of, I'll pull out the cosine of x here, just write it out front, cosine of x times sine of h over h. And this is where our special limits are going to come into play, because the limit as cosine of h minus 1 over h goes to, as h goes to 0, that limit's going to 0. And the limit of sine of h over h as h goes to 0 is going to 1. So once we do this, all we're left with is the limit as h approaches 0 of, we'll write it out, the limit as h approaches 0 of cosine of x times 1, and x doesn't depend on h at all, so this is just going to go ahead and be cosine of x, which is exactly what we know the derivative of sine should be. So what we saw is that when we used the sine addition formula, we were able to expand it out, do some grouping, do some factoring, and after we did that factoring, our two special limits kind of popped out of our limit formula. So once we did that, we were able to use those special limits to go ahead and simplify down until we had that the derivative of sine of x equals cosine of x.